1.2 today, guys, which is all about cube roots. Okay, so let's talk about what is the parent equation for a cube root function. So that would be the cube root of x. Okay? So why don't we take out our calculators, go to a graphing page, and let's graph the cube root. So how do I get to the cube root? Circle. So control and then this little arrow up and down next to the 4. Make sure you put 3 is the little small number and then x. Okay? All right. So we look like this. Okay? It's just a different color. Shh. Focus. You guys. Do you see the graphed cubed root? Okay. What does the domain look like it's doing? Do you think we're going on and on forever in either direction?
Yes.
Yes. So we call that all real. Do you think if we went on, eventually we would cover all the y's?
No.
Look at it.
Yeah.
Is it going slightly up?
Oh, yes.
Oh, yeah.
So if we go to infinity, it would eventually go to infinity, right?
Yes.
So we call that all real.
Oh, sorry. Because
The y value, excuse me, it keeps increasing or going up. Shh. I'm recording this. Okay.
Pardon for the interruption. Attention all staff. At this time, could you please dismiss the boys and girls varsity track team to meet their bus in front of the arts and recreation doors? Once again, please dismiss the girls and boys varsity track team to meet their bus in front of the arts and recreation doors. Thank you.
Okay.
Do you need to see us clear these calculators?
Yes. Ashton, where's your clear calculator? Where's your clear calculator? Go, grab your clear calculator.
Are we supposed to grab it?
Okay, you are supposed to graph it, so if you hit Control T, you'd see a table, and I would graph 0, 1, and 2,
There's 2.
and -1, and -2. Thank you, I know that was a pain. So you hit E.
Or table. Virtual table. That works way better.
Control T. Yeah. Okay. So I've got this right here. Now my x-intercept and my y-intercept should be the same.
So be positive and negative.
So it should be the x-intercept is 0, 0,
The door. Oh, okay.
and the y-intercept is 0, 0. Jaden, would you shut the door for me, please?
Why would it be?
Thank you. Because that's where it crosses, right? Crosses the x-axis and the y-axis at both at 0. Okay. So we're going to talk about the coordinates for 3 major points. I'm just going to pick 3. You tell me what they are, okay? What is -2? What is the y value? So you can hit Control Table and look at your graph and your graphing calculator.
-2?
At -8, excuse me.
I know. I was close.
-2, yeah, I gave the answer away. Okay. At 1. Look at 1. If you look at x equals 1, 1. And if we look at x equals 8, what's y equal 2?
What?
Okay.
What? What do you mean? Why are those numbers?
I just picked them. I said put 3 major ones down, and I said I'm going to pick them, and then I picked them, and I said find them.
So we
I would never give you a question like this in a test or quiz. This is just to kind of get the point of the graph.
and for this graph, those are the only points.
Okay. Let's talk about our cube root idea. Okay, what does, when we think back to vertex form, or we think about what we did yesterday, what does A do?
I don't know. Left
No, let's think about, let's skip A for a second. What does H do?
Goes left and right.
Left and right. And it's kind of the opposite of what it says, right? If it says -2, I know I move to the right 2.
Yeah.
If it says +3, I know I move to the left 3. Right?
So
Opposite. Yeah, you might want to write a little note to yourself. Opposite.
Opposite of what?
What it says.
Oh, okay.
Okay, what does K do?
Up and down.
Up and down. Okay, let's think about that A.
Times that.
Skinnier or wider? And what else could it change? What if I stuck a negative in front of it? It'd flip it. Flip.
Open.
So it doesn't really open because it's not the same thing, right?
Yeah.
So if we look at this, don't write this in. The negative would be like that, right? That would be the square negative cube root. Okay, opposite. Flip it. Okay, so we're going to say how this changed from the parent function. So the cube root of x minus 3 makes it do what? Am I going to move up, down, right, left, skinnier, wider?
To the right 3.
Right 3. What about B?
Left 4.
Okay. Okay, let's look for C. I recommend us looking at what it looks like in the graph. So I'm going to put it in. I'm going to hit tab, and then I'm going to put control, my little up arrow, and I'm going to put -3, 3, x. Then that little 3, then that x. Just like it's written right. Then I'm going to hit enter. What did that do?
That made it flipped it.
It flipped it, right? And what else did it do?
Made it wider.
I would say stretched it up. How about we say that?
Yeah.
Stretched it up. Okay, what if we add a 5 to the outside?
It would go up 5.
Up 5. What if we subtracted 6 to not underneath the square root? Down 6. Okay, F is hard. We've got a lot of different things here. What are we doing? Let's talk about what, do we move it right or left?
We move it right. Left.
Right.
Right.
You're right first. Right, how many? 2.
I thought that was up
Remember,
and
it's the opposite.
and then down.
A is the up and
Outside.
down.
I'm not looking at A. I looked at H.
I mean H. Yeah. I thought H was
H,
up and down.
no, you got it right this whole time, and then you messed up. Look, see, H says, what does H say right here? Okay. What
Oh,
does,
yeah, you know,
yes.
Why did you make those? Yeah.
I'm sorry, I can't hear you because Caleb was still shocking himself. Sorry.
Why did you keep
What do you mean, did I keep D&E the same? I just said what it is. 5.
Because for A, it's like -3, but it's right instead of left.
See how this continues, that line, the cube root line, where the cube root line does not continue, it stops right there. This is that's kind of what Grace was asking for her homework last night, right, when she was doing square. Okay. So I moved right to, what is that 7 on the outside going to do?
Up 7.
Up 7. Okay, now let's do A, the hard part. What's that going to do?
Stretches it out.
Stretches it up, we're going to say, yeah.
And it's opposite.
And if it's negative, you stretch down.
If it's negative, I flip it and stretch it. I'm not. So let's put that last one in. I'm going to show you. You don't have to do it on yours. Let me just do it on mine. Let me just do it on mine. So I've got I've got F. So see how it looks the same? I've got positive 3 times the cube root of x minus 2, and then outside that plus 7. See how it moved it? Let's look. That's kind of the best example. See, it moved it 2 to the right, up 7, and it moved it so it increased my slope, made the slope steeper. All right, let's look at 8. Okay, let's talk about what it does to the domain and range. Okay, when I times it by 5, does it change my domain to anything? No, these are all real. Can I do just a big R where I double do it and that means all real? They do like that. It's quicker. Means the same thing.
Wait, why are they all real?
When I put it in my calculator, it doesn't change it, right?
Pardon for the interruption, attention all staff. At this time, could you please dismiss the girls' JV and varsity tennis team to meet their bus at the left-hand pool doors? Once again, please dismiss the girls' JV and varsity tennis team to meet their bus at the left-hand pool doors. Thank you.
Okay, so let's look. If we look at the cube root right here, all my domain and range is always going to be all real, right? Look how I flipped it to show the negative 1. Does that change it at all?
No.
No. All of these are all the same. They're all real numbers.
That's what I thought.
All of them. The point is so that you don't forget.
Is that an L?
It's a double R. Double stem R, which means all real numbers. When you're not a cube roots, always all real. Doesn't ever change. Okay?
For both domain.
Yes.
Wait,
For squared, it's different.
okay, so for all cube roots, it's all real. It's all real.
Yeah.
Okay, because it's making me confused. Why are they all real?
Okay. So we're going to look at A. We've got negative the square root, the cube root of x. So remember, it's the opposite. Okay? So this one, when I still have 0, 0, but 1 would be negative 1. 8 would be negative 2. Negative 1 would be 1, and 8, negative 8 would be 2. So yeah, if we look at the parent function, I'm always going to do negative 8, negative 1, 0, 1, and 8. Okay? And that gives me negative 2, negative 1, 0, 1, and 2. Okay? All I'm doing for this one is I'm flipping them. So when I have negative 8, I'm going to use 2.
So the parent function is always going to be.
Yeah, this is the cube root.
Yeah, okay.
Okay.
So if you change it to a negative,
Yeah.
flip it.
Yeah.
Yeah.
Okay. The domain and range are all real. Okay. B. I am going to move this to the left 5. So 1, 2, 3, 4, 5. And I'm going to stretch it by 3. Again, you've got a graphing calculator right next to you. I might do it in my graphing calculator because that makes my life easier. Right? You have Desmos at home. Otherwise, you can graph it by hand. And the way you graph it by hand is you're just plugging these numbers in. Again. So I hit Control T, and I get a nice little table. Okay. So I know that it moves to the right 5. Okay, but it's stretching it out 3. So I've got.
Do you go over 3 from 5 or do you go to 3?
So it's 3. So my next one, I've got negative 4. I've got 3. So that means negative 6. I have negative 3. Okay. Yes.
You can do 4. What did you write for domain and range? What is that?
Domain and range is all real numbers, just like I discussed up here. And I said, can I use this instead?
That's what you
Sure did. Okay. I know, if you just don't look up here for a second, guys, you miss so much.
I have negative 5
And
and
at 3, I'm at 6. So I start going like this, like this. My domain and range is all real.
What about the 5 and 0? Negative 5 and 0.
I have it right here.
Oh, yeah.
So as I told you, you're going to have to pick points then that go in there. So C, I'm at 0, 0, but I'm going to move down 2. Okay? So I'm going to take this. Okay? I'm going to have negative 8, negative 1, 0, 1, and 8 might be an example. At 0, I'm down 2. So at negative 8, what would I going to be down? So at negative 8, the cube root of negative 8 is 2. 2 minus 2 is 0.
Oh, you can also put the table for this, too? So that they-
Yeah, Grace asked me specifically. 8. The cube root of 8 is 2. 2 minus 2 is 0. Okay? The cube root of negative 1 is 1. 1 minus 2 is negative 1. 1 minus 2 is, yeah, hold on. I'm confused myself. The cube root of negative 1 is negative 1, excuse me. So negative 1 minus 2 means this is 3.
Yeah.
The cube root of 1 is 1. 1 minus 2 is negative 1. So we should have, and the cube root of negative 8 is negative 2. Negative 2 minus 2 should be negative 4. There we go. Negative 8 should be negative 4. Negative 1 should be negative 3. 1 should
Good
be
afternoon, Lincoln High School. This is Drew Boss
And Marlene Goff.
with your afternoon
no, 1 should
announcement.
be negative 1, excuse me.
Seniors who would like to participate
should go
in
like
the
this.
graduation walk through the elementary school can sign up at the counseling office. This will take place
All
on May
real numbers.
29th after cap and gown pickup.
Okay, you do not have to finish this and do the bottom. The other one is your homework. The other sheet, 10.2, additional practice. I'm going to stop the recording now.
Attendance officer